Hello, this is Professor Mike Labasi, and this is for my CIS 2808 Digital Forensics course. And this is a look at Topic 8, or Network Forensics. And this is looking at our Volume 3 of Chapter 1 of our CHFI content. So itself is Network Forensics. This is Module 8. And we're going to take a look at some of the concepts here that are important to look at. So before we jump into that, we're going to take a look at this actual this is recommended post or URL from the course of textbook, recommended reading. That's a nice little summary of what is forensics. Network forensics itself, I'm going to say this, it comes down to logs. It's about log parsing. And so we have a lot of noise generated from a lot of devices, routers, Wi-Fi access points, firewalls. And so there's some concepts in the chapter that are really important to look at. But we gotta say it's about capturing logs and really using a post-mortem fashion. Now there is going to be some stuff with real-time analysis, catches as you can technique here, and we talk about here like recognition, safeguarding, and sometimes you will use logs to train your firewall or anything, it could be FireEye or some other third party sitting outside your network to help prevent uh, so you want to preserve or prevent others from doing this. So sometimes it could be the post-mortem will come out of this, and it can be used to tune firewall um, or other security devices. So a lot of times it's going to be rule-based. So we'll look at some of that here in a second. And so the chapter delves into both the analysis and some of the work to prevent. But accumulating, observation, and investigation. So this is really good stuff here. Now, of course, accumulating, this is a problem. uh, And we'll see it's important though with some concepts for the legality of logs, but it's important we look at this here. So, but we'll look at the investigation part itself. So of course you always want to safeguard the evidence, but we'll come right out and say this. You're not going to take, Amazon's not going to take down Amazon.com because of an attack. You could take possible infected images, virtual machines, or in case cloud instances of servers, and you can spin up new ones and then freeze those ones, leave them as is, and remove them from the production queue. So you got to remember it's going to be pretty rare where you'll just have the entire system presented to you. Here's our network server, here's our firewall with all the evidence on it. So you're going to have what's going to be a copy or best evidence rule copy of the logs. And so this should be preserved as best as possible. And so that could include getting a certified copy from the company. Maybe you're doing as contract work, and maybe performing an MD5 or a SHA1 on it, and then keeping that password protected and making a copy of that, so never altering the original log, especially if you're dealing with legalities here. Now, a lot of times, some of this forensics work is again this CHFI, right? Um, so you know so are you being hacked already? So sometimes this work is going to come from an internal security team. And so some of these preserving logs for legalities might not be as, maybe not needed for the legality sense, but you want to keep a copy of the log archived to go back and look at it in case you need to do some follow-up. But the post-mortem is going to be a huge deal. And then what comes out of that. But again, if it's either going to be in court, if it's legalities, you got to make sure um, it's got to be, of course, well written, how you look at the logs and so on. But look at this, instant response is really where I think you're going to come down to. So it's going to be a little faster, a little quicker work to find out who tried to hack or who hacked what page or what aspect of our network, and then can we mitigate or block it? Patching, it could be mitigation strategies, and then quickly get those in place, test them, make sure they don't break anything else, and get those in place quickly. So it could be a little leaner, meaner machine versus bring it to court. So just keep that in mind. There's two ways to look at this. So, but if we look at the network forensics itself, um, again, I can't say this as much. So you're looking for the source, the path. So I'm going to use a marker here. So the source. Okay, that looks horrible. There we go. The source of the incidents, the path of intrusion if all possible, and the technique. Now, traces evidence is definitely something you like to have. This sort of really becomes that. And so logs are going to be a huge part of this. Now, this can be a very complex thing because of the lot of a lot of things in motion here, a lot of different complex parts of our system. And a lot of times you're not going to really record network traffic. This is something that some labs will say, yeah, you take the PCAP file that was recorded and you put that in there. Recording traffic is really something that is only done usually after the fact or maybe turned on during the actual attack. So this is something to consider that you might not have like a PCAP file. Um, this it takes a lot of space and a lot of resources to capture all network traffic. Now again, third party like maybe like FireEye or something like that might have something that sits out in front and can offer that service, but then you pay for that. So turn that off there. All right. So next one here, moving on. So again, for postmortem and real-time analysis. So there's two ways to look at this. Pretty straightforward. Ongoing attack, something's already going on, and this is going to really be your sort of incident response side of the house. This is also incident response, but it's also is mostly going to be incident response. Also, maybe about criminal investigation. Uh, so it's and this is what usually happens. Some of it has already happened. Um, Analysis of logs. I can't say as much. This is really going to be happen, and this will go into a post-mortem. And some of these rules can go into creating a real-time analysis, maybe a rule set to help prevent future attacks. So these work hand in hand together. So just some of the things you look for, and this is one of the tables from the textbook. Um, Most common network attacks, denial of service, of course, being a huge one. Man in the middle, that's a tough one to find. But packet sniffing, enumeration, session hijacking. Now, some of these are going to be from maybe a pen test. Anyway, of course, we also have actual Wi-Fi jamming attacks and so on. One of the big ones here is, they have it listed, rogue access point. Sometimes this is not malicious. I've seen this before where it's the rogue access point. It really is, it's called shadow IT. So large company, you have horrible Wi-Fi in your corner of the office. You put in a ticket for it, IT says it's fine. And so you and a few other folks and get together and you buy your own access point and you plug into the network wall and voila, you have your own sort of private access point. Well, that can become a security issue because it's unpatched, it's not configured correctly. Um, it may be, a lot of these things come in um, and allows for people to come in like a side channel attack. So it's called shadow IT. It also can come up to the fact where it could be a sales department hires some third party to set up a sales page, and they tie in maybe network credentials as a part of the login to that page. It's the same network credentials that are used for the company, and that, of course, that company does not have a well-rounded security, and then hence that is an issue. So, okay, so move off of that. Um, so from all this stuff, all this in things, you want to come up with the indicators of compromise or IOCs. This is a really good thing to look at. Um, Indicators of compromise. These are artifacts. These are things you could record from the logs or from related systems, applications, so on. And here's the type of logs you would look at: system logs, applications logs, network logs, firewall logs, client logs, and so on. And so we're looking for things like unusual increase of outbound traffic. That's a good one, but not all attacks are inbound. I like that. Um, the attack itself, and I'll diagram this here, could initially be captured from a client, but it's sending a lot of stuff out, hence the target attack indicator that people are siphoning our data out of our system. Phishing, scamming, so email here. Another one in that here is email. Definitely email for phishing. Email logs. User agent strings and so on. This could be parsed in from your firewall. Everything that comes in uses a user agent to it, and typically you can do rules based on that. So that the type of browser, the type of operating system. And here we go. Log anomalies, increase in failed login attempts. That's a big one. I mean, pretty straightforward. And so, is it tied to a single IP address, for example? Single IP address, we see a huge amount of failed login attempts. It looks like a brute force attack. So that could be a real-time analysis that ends up having a rule that sort of stops that IP address for a short amount of time. Increased number of same requests from the same file. This could be one really trying to get a certain thing. Or also unusual ports being used. So this is just examples, some indicators of compromise we'll see. And so where to look? This is great. I'm glad they bring us in here. I've always said the TCP/IP model, the OSI model, is a great way to look at this. So I like the TCP model, makes more sense. It's a little more, it's shorter stack. It makes more sense. You can directly draw to certain functions and protocols. And this is great. What's the function? Is it the application itself, the web app layer? So we're looking at FTP, DNS, so on. So we can look at the protocols. And knowing the protocol, this kind of stuff is usually logged. The protocol type, the server, the date, time. And so you pick out these specific metrics you need to pin down and use to look for certain attacks. So in this case, firewall IDS. So looking for a huge spike in TCP for a specific endpoint, internet layer, and so on. Certain IP address again here. So you can see where these applications could come from. Firewall's a big one you can see, but router and switches too. So our network layer. So again, we're looking at specific types of ARP poisoning or DNS, things like that. So I'll move on here. So I like to have that slide. It's a really good slide. So all right. So again, what kind of data we're gonna look at? This is a great slide here. Don't specifically have full content data. I don't think you're gonna have all the packets. Now, this could come as during an attack. Maybe the instant response is to turn on some sort of TCP dump and record it while it's happening. It's possible. If so, you have this. This is, of course, our PCAP files. But really looking at is this alert data and probably session data or calls with log data itself. So now you could dump all this stuff into and create statistical data. So summaries of network traffic with timestamps, protocols. Again, these are things you want to look at, and services. Those are probably the big ones right here. Those are going to help you narrow down from all this noise where the attack is coming from and what type of attack it was. So said it before, log files. This is where it's at. It's all about the log files. So they can be tampered with, but unless, of course, there's a possibility of certain false entries to the logs. So that's something to check for. Is also the integrity of your log files. Now, there's some logging rules to put in place that larger corporations might use that small ones won't. Something to look at this. But again, there's steps here. We need to make sure that the logs are a testimonial evidence. They demonstrate the reliability and folding intact. So let's talk about that here. So this is an important thing. You can't just create a log for just the attack. There's supposed to be certain standards. And here we see the FISMA, HIPAA, so on. They have to be fully sound manner logs. So what does that mean? So must be consistently with the event under investigation. I mean, the log applies to it. It's preferred in a stored location, prevent tampering. So there's a concept about a log server. So what you might see is, I'm just going to draw on this slide right here. We have a firewall here. We have behind it we have maybe an app server and a couple web servers, and they will cut logs to their own local directory, but they also cut logs to a logging server. That's a one-way read, one-way only, and they come here as read-only. And then these logging servers is what like IDSs, intrusion detection systems might use, or other things will harvest this. This is where you use the CPU to create those little pretty graphs and things you see on like SecOps, all those big graphs and data analysis. You don't want to do that kind of analysis on the servers. The reason being is if someone goes in and tampers with this log after it's cut, there could be a difference. So you could do MD5 hash. This log and this log are different. Why is that? This one was tampered with. This is the original copy that was read-only sent before or was copied before the tampering was done. So if that exists, keep in mind you want to pull from the logging server, but this is probably going to have this um, this stored in secure location will be check that box. Um, and this is a big one here. It's part of routine business practice. So the idea is we created this log just for the attack. Um, it could come into suspect as this is not a normal routine business logging. So, and it's not an issue. You get all kinds of logging from all kinds of systems. So there's very the fact there's a lack of logging is going to be pretty rare. So, but there's a federal rule of evidence 803 here. So it's important that this record is again, read that out there. I'm not going to read it to you. That's it's trustworthiness, and it's really a part of conductive business. That's probably the biggest one there. So part of showing the log is showing how we do the logging, and could become in court saying this. We normally log this information from the firewall and from the DNS server and from the web server. Those go into our logging server, which is a read-only, a one-way write-only type of or read-only. Initial storage, and then it gets copied from there and it's done for data analysis into our database, maybe Splunk, for example. So you can put that chain together and show it's regularly part of the regular business and say, in this logging, we found this IP address from our attacker here performing these types of evidence that are indicators of compromise. Um, so again, credibility and usability is huge here. This is a big one. And this is a great list here. Log everything. That's a big problem, but is possible. Synchronized time. That's a huge one. So most servers use some sort of universal time synchronization. Uh, so if the date times are off, that could be a huge issue. Multiple sensors is a great one. So missing logs. So you gotta make sure they're not missing. If someone's messed with the log file itself, you could put a alarm on that. And of course, up to date hot fixes and so on. So I think those first few ones are important. Again, file authenticity. Again, because you're not going to have the Amazon server pulled out and put onto an evidence cart and wheeled into um, the courtroom. So you have to show that these are authentic files that came from the server. Server's still gonna be running probably. Maybe it's frozen, but maybe it was removed. But um, they've been moved off to a master server, and maybe a portable disk, and then held as evidence. So talked about this already. Centralized logging is usually best practice, and this is gonna be where you're gonna get your stuff from. Let's see if there's a centralized logging system in place. It's really gonna check those boxes. So again, here we go. So event correlation. So you have all this information about logs. How do you correlate it? So the chapter goes into a lot of detail, different tools, and different ways to correlate. Definitely, you can set your time intervals. It's going to be important to look at. And of course, you just can't grab it. So there should be a start and end time. And then from those, we should have, of course, a standard date time to use, right? And I say, what is it? It's the log is doing EST. Are they doing universal time, whatever, or GMT? And if so, you got to make sure you have those correlated. So most log management platforms might do this, but it's going to help you aggregate the events and then mask out anything you need to find, and then find the filter and find the root cause. So this is sort of a funnel effect here. So we aggregate all the logs. We only get what we need from the logs. We mask out certain things we don't need, and then we filter that stuff. And what comes out of it is, of course, hopefully our root cause analysis. So same platform, cross-platform. Chances are it's going to be cross-platform. You could be dealing with Linux and Microsoft. This is where the date timestamps could look different. Logging. The good news is there's a lot of stuff to help with this. You're not going to be stuck writing some raw Python script to parse this stuff. There are ways to do this. So firewall logs, again, a great point of entry. I mean, makes sense, right? That's what their job is. So URLs, IP addresses, queries, um, and of course IDS logs. If you have any kind of intrusion detection system in place, I mean, this is what their job is. So um, yeah, I mean, failure to comply with protocol syntax, unexpected elements, that's a good one. Someone sending in or fuzzing a form. Repeated traffic, that's a huge indicator of compromise. And of course, that anomalies there. Again, you want to find out, is there someone who can't type in our password a few times versus someone who's been brute forcing us? So router logs, just some examples here. I'm not going to go over this example, but verify the date timestamps and understand the date timestamps as they come in from the router versus the firewall. And so, and of course, Windows itself might have a different, the DHCP Windows server might have a different date timestamp, hence our activity. But understanding the logs themselves. So going back to the documentation for Microsoft or for Apache and find out how the logs are set up. It also could be log configuration files that dictates how the logs are laid out. So why investigate traffic? Well, why not? I mean, of course, is it an ongoing attack? Is it a security intrusion? Um, if it's a live one and you maybe turn down a PCAP file, there's Wireshark. You've seen Wireshark already in plenty of classes. This is a fantastic tool. It's an amazing tool. Just keep that in mind. It's a way. This is probably the way to use for TCP dump, or you want to get those PCAP files. And of course, centralized logging, the security information event management. Now this costs money, but it has built analytics and log management. And what happens is you get um, from your firewall, your database, your apps, routers, little computer chips, whatever it is. If it makes a log, it can go to log management and it can be analyzed. And now this, of course, is going to cost some cash. And sometimes there's even a fee for those, a licensing fee monthly. So just as an idea here is if it's coming from a large company that has that, it's going to make the job a lot easier. So, but some things to consider is this, is you try to do is trace out a path of attack here. So, and so itself, again, maybe it's coming from the web, coming in from the web. So again, our firewall, maybe we have a load balancer in place that might have some traffic on it. Of course, here's our DMZ. So here we have, of course, we have some web servers here possibly. There, of course, are going to have logs cut, but maybe only one server is attacked, and hence it's breached, and it gets to the firewall. Again, log number 2, or the internal router log. It goes to another internal system. Maybe this is a backup server. Again, so you can see where the logs are going to come into play here, and track down someone to try to get. Maybe they got this far, and they were blocked. Maybe they got all the way into the data center. This is the target. This is what we want to get to, right? Our data center, our database. So, but also think about the other direction. So here we have maybe a wireless network that was compromised, and we have a client here that clicked on something. Oops, and I want to move that. That went out to the web. So again, it's going to go through, I didn't draw it correctly, go through the firewall here, network server here, and so on. There could be a wireless LAN server that's hopped off of that too. Or it could be someone clicked onto a phishing scam. And so also look for the outgoing traffic, because this internal click from a client here, goes to the network server, out to the firewall, and out to the DMZ firewall. So you can see where, and of course it goes to some bad website, and that in turn initiates the incoming attack. So, and now we have the incoming attack, which actually goes to the firewall, but goes back to the client, and then the client gets used as a pivot point. So the term pivot, and this is what it means, is not all attackers come straight in and attack come straight in and do this. Sometimes the attacker will try to get a foothold here, or maybe with a client, and this is probably the biggest one. Social engineering, phishing, this client hold opens up the door for someone to get here. So not all attacks are going to come from here. They will actually maybe start, they are linked back. They open up a port. You see maybe in a remote desktop or RDP or a remote port, and the attacker uses this as their attack point. So just remember that not everything starts from the outside and comes straight in, and everything is it's a mismatch. So where to grab the logs is going to be it's key. So knowing sort of the topology of the network is going to be a key thing. So anyways, I just want to add that note there. I think just to wrap it up here, we'll look at there we go. And this is some examples. So this is actually from the lab itself, and this is an example using Splunk to actually pin down 2 IP addresses of interest. So this is the masking part, and you can only do selected fields. So, and that's the idea here is um, we're using selected fields. I only need to know these fields for these things. So we have filtering, masking, and that's going to help you pin down in this lab here so you can see what field you want. And that's the thing is there's a lot of noise here. This case came from a CSV file called brute force CSV, but you can see there's certain things we're on for. Response 530, user cannot do this, cannot log in. So you want that. This is our filtering again, and now we know what we want. This is our indicator of compromise, and we get tied down to an IP address, an attack vector, and we have a host. So you can see things sort of fall into place, and this is where a tool like Splunk, which is a fantastic tool, or some other tools like it, are going to help you quickly find the signal in the noise. So anyways, I'll go through the full lab there, but that's the idea of Splunk there from the lab. So anyways, that's it. Here's a summary you can look at as we wrap up here. Again, I can't say as much. Logs are going to be your primary thing, and having those logs accuracy and their credibility is very important, especially if it's going to uh, go to a court of law. Otherwise, yeah, there's some leeway there. If it's an internal thing, internal response team, a quick, hacking investigation, CHFI, right? It's a hacking and forensics investigator, and that way you can, fix or mitigate it, and then fix the incident response. And now, how do you handle that the future attacks like that? So that's it for the chapter, and thanks for watching.